presentation today. Okay, so here's our slide. We promise to make this as brief as possible, so we are hoping that in about an hour we should be able to round up with today's session. So we're just going to go ahead and start. So far, from the first 2 days, we've learned quite a lot of things. We've learned about the R vectors, and we said there are 4 common atomic vectors. We said they are double, integer, logical, and characters. Okay, and we said there are a few augmented vectors. We also mentioned the 4 of them. We said there are factors, date, time, and duration. All right, and we said practically all of your interaction with R, you'll be doing them using functions. Okay, we said functions are embedded in what we call packages. So a package is a group of functions that perform similar tasks. And everything you do in R probably you'll be doing them using functions embedded in packages. We also talked about how to manage your project. And we talked about how to manage your files, especially how do you get your files into R? How do you do some level of data cleaning? And we did that together yesterday. All right, so what are we going to be learning today? Basically, today is the icing on the cake. We're going to be plotting charts. We see a few charts in action. We're also going to be seeing how to save outputs. I'll talk a little bit about how do you communicate your result. For example, I told us on day 1 that this particular slides, all the slides that I've been presenting, I made them with R. Okay, so R can be used to create slides, powerful slides, right? Now we're going to do a brief recap of everything we've learned. And I'm going to point us in the direction of few resources going forward that might be useful for us, right? So when you want to plot charts in R, there are a whole lot of packages that you can use. And those packages came at different times and they came for different purposes. Like a few years ago, plots in R used to be very boring, but several packages came up after that, and they can help you create beautiful slides. We're going to see a few of them in action. But for the purpose of this class, we'll be focusing on the ggplot2 package. The package we'll be using for plotting is called ggplot2. Please note the gg is always in lower letters, ggplot2, all right? But generally, R can help you plot static graphs. Static in the sense that they're just like pictures, PNG, PDF, and something like that. Or you can have HTML widgets. We'll see examples of HTML widgets today. Or you can do absolutely interactive tasks. Interactive are usually what you see when you go to websites with R dashboards. You can interact with charts, you can set your parameters and then change the plot and things like that. But we're really not going to be talking about that today, but it's good to know that R can also do interactive tasks. Again, like we said on the first day, the type of chart that you're going to plot will depend on the type of data or the variables that you have. For example, you would not go ahead and plot bar chart for continuous variables. Okay, we talked about that. Now, bar charts are not used for.
Excuse me, please.
Okay.
Hello.
All right.
Hello.
Okay, so for
yes, Mr. Stephen.
ggplot2, basically it follows what we call the grammar of graphics, right? The grammar of graphics is saying that how does ggplot2 plot a chart? And the grammar says that there are about 7 different parameters that ggplot2 considers. We call them elements. There's going to be the data, what data are you plotting? It's going to have to map to the x-axis, to the y-axis, probably map column, map shape, map sizes, and other things like that to a particular parameter. For example, what do you want plotted on the x-axis? What do you want plotted by the y-axis? Do you also want to map to a particular color to a particular variable, which we're going to see in action in a bit. Then it has geometries. Geometries are basically the type of plot you want to plot. The type of chart you want to plot. So bar chart is the type of geometry. Line chart is the type of geometry. Scatter diagram is the type of geometry, and things like that. And it has what they call themes. For most of us, I'm hoping that we're familiar with what themes. Themes have to do with appearance. You want to do some color formatting and all those other things, you do it with themes. We're going to focus more on this first today, and we're going to see them in action. The data, the aesthetics, the geometry, and the themes. But there are 3 additional ones that I wouldn't really bore us with, but they're here, all right? So a little bit more on those 7 elements. So I've decided for the data, of course, is always your variable of interest. The aesthetics, I've talked about X, Y, and a few other additional aesthetics that you can plot. X, Y, color, field, size, label, alpha, shape, line type, line width. Those are about 10 of them that you can map your data to. We will see example. For example, like I said, yeah, what do you want on the x-axis? What do you want on the y-axis? Do you want to fill them by a particular variable? Do you want to plot, for example, bubble charts? Then that's the size will be mapped to a particular variable, all right? Now, I've also talked about the geometries, point, line, histogram, and the rest of them. We've also talked about themes and the other ones you can look at them. So this is basically what it looks like when you plot. You're going to add your data layer first, the yellow at the bottom. Then you're going to add your aesthetics on that. Then you're going to add your geometry. Then you're going to add a theme. And minimum, those 4 criteria. All right? The data, the aesthetics, the geometry, and then the theme. All right. So we'll see that in action. Basically, this is how the format for GDP package looks like. We recall yesterday that what we were talking about was a lot of then, this percent greater than percent. But ggplot2 unfortunately came before then was introduced. All right. So instead of then, ggplot2 uses plus. So it's going to ask you your data, then add your aesthetics, plus add your geometry type, plus specify your theme. Right? Or you can do it this other way. ggplot your data, comma, your aesthetics, plus this, and then plus your theme. Generally, I tend to favor the pattern in red, the one on the left and on the right. ggplot2 is really not an abbreviation. That's the name of the package, right? So it's really not an abbreviation. Just like we had Tiger, Reader, Deployer, and the rest of them, ggplot2 is just the name of the package, not an abbreviation. Okay? Now we're briefly going to talk about saving your plots. And recall that when we were importing our plots, we used the import function from real package. So for saving, we're also going to use the export function from real package, meaning that we want to take our output out of R and put it maybe on our local folder or something like that. And you can use export to export several types of file, but we're going to see for CSV and then we're going to see for Excel. So I'm going to allow us to stop here right now, and then we'll go back to our work yesterday and do some plotting. Then we're going to come back with these slides. So I'm going to stop sharing this now. And I'm going to share my work environment. Okay. So what I'm going to do is I'm going to assume that I am reopening my project altogether, meaning that I closed it after yesterday and I reopened it. All right, so when you close and you reopen, your environment will be empty. Sometimes you might also not even have any script opened. All right, so you just go to your R folder and you will see your scripts there. So this demo underscore analysis was what we were working on yesterday. So I'll just open that up. So my script is up. And I'm just going over what we did yesterday. We did load the library Pacman, and we used the Pacman, p underscore load function from Pacman. So there's just one thing I want to quickly mention, and I hope I really don't confuse us. If we look all through our script so far, we only use p underscore load just once, even though it is from the Pacman package. And p underscore load for now is the only function we have used from the Pacman package. Right? So when you have instances like this, then it is also possible for you to be able to, instead of loading library Pacman, I'm going to put a comment on that by putting sign in front. I'm going to say Pacman : pload. Okay, so when you do something like Pacman : pload, and I'm doing this because out there you will see examples like this, and it probably interests you. You want to know more about it. So when you do Pacman : p underscore load, you are saying from the Pacman package, allow me to access the p underscore load function. All right. So you are not loading the library. You're just using only one function from it. Okay, so I'm going to go ahead and run this by clicking on my run. And now, because I already downloaded this file from this URL, I don't want to re-download every time I run my analysis. This has already been done. I'm supposed to download my raw data just once. So I'm going to put a comment on this. I don't need it again. Hold on, please give me. I'm so sorry about that. So I'm back. So I said, because I won't have to re-download my raw data every time, I'm just going to put a comment in front of that so that when I run my code, it doesn't download again. Okay. At the same time, I'm also going to put comments in front of this. Okay, that's why I got an error, because you couldn't find the URL. So again, when you're downloading from the internet, you don't want your R script to keep downloading every now and then because you already have the folder. Just comment it out. Don't delete it. Better to comment it so that people can know that if you're running this for the first time, you might have to download this folder, this file, and after that, you will have it on your local system. All right. So I'm going to run the local copy that I have, and then I'm going to continue and then running my scripts. And if you look at my environment, everything is getting populated there, right? So it's also good sometimes to redo this because you might realize that along the line, your code is breaking for some reasons. Maybe because you did some modifications in the console yesterday and you did not remember to put them in the script, and it's breaking your code. This allows you to be able to figure it out early and make the necessary correction. My code is not breaking yet. Everything is working, right? Then I have all of this. This works. And then we answered these 3 questions yesterday. The first question was, how many respondents from each state? We did answer that. The second question was, how many people have systolic hypertension? We answered that, and we used 2 different methods. The third question was, for each gender in each state, what are the average age, height, and weight, and we did that. So we have 2 more questions that we are yet to answer, right? So let's quickly look at what the questions are. The next question says, plot a graph of the gender distribution. So it's about data visualization now. So question 4. Plot the graph of the gender distribution. Now let's look at our data again. This is the gender. So it's asking us how many males, how many females, and it wants to see it as plots. Let us assume for a minute that it wants to see it as a table. We would have done something like this. Our df underscore csv underscore clean, and we would have called then count x, and we will see it. But it's saying no, I don't want to see it as a table like this. I want to see it as a plot. So how do I do that? So let's remember the format for ggplot2. First thing, we need to come back to where we loaded our packages and include ggplot2 package. All right? So we're going to come here and say, also load ggplot2. I'm going to include one more package. It's called Plotly. I will see Plotly in action in a bit. So I'm going to come here and say ggplot2 for static graphs. And Plotly is for widgets, for HTML widgets. And we're going to see that in a bit. Okay. Then I'm going to run these lines of code again so that ggplot2 is loaded and then Plotly is loaded. Again, don't worry if you have not installed ggplot2 before or you have not installed Plotly. When you run it on your own computer, p_load will check if you have it pre-installed. If not, it will install it, then load it. Okay. We're going to come to the ggplot2 format. It says the first is the data you want to use. Then ggplot, that's the guidance that we provided earlier. Yes, you can load ggplot2 at the start, but we didn't include it yesterday because we didn't need it. So I'm just including it today because this is when we need it. Again, I said, try not to load any package that you do not need because it consumes your computer's memory. We need it today, so I'm loading it today. So just include it in your line of packages to load and rerun that chunk of code chunk. All right. So it's ggplot mapping equals aesthetics. Now, if you look at a plot of sex, sex is a categorical variable. Only one categorical variable. So meaning that we only have just one x-axis. Sorry, we only have one axis, which is our x-axis. We're going to have the text on the x-axis, and on the y-axis, we're going to have the counts. All right? But as you can see, even when we use this code up here, let me bring up the code again. This one, we're only counting just one variable. R automatically determines the number of each of the gender, the sex in our data, and it's putting it as n. All right. So it's the same way. This is one of the good advantages of R. For example, in Excel, maybe what you would have done is to manually create this type of table, and then you're going to do X as this, Y as that. That is also possible in R, and I'll show us in a bit. But most times, you don't need to do this manually. Okay, because like I said again, in Excel, you would have said, okay, x-axis, sex should go to the x-axis, and n should go to the y-axis. All right? But in R, you won't need this intermediate step. R can automatically do that for you. So you just specify your x-axis, which is sex. Then the next thing is the type of geometry that we want to plot. Film underscore. This time around, we are plotting bar. Okay? Most times this is enough. There is a default theme. We said the fourth layer should have been a theme. Theme underscore something. But ggplot2 has a default theme. It's called the gray looking theme. It's gray, and we'll see it in a bit. So I want to add a theme here. I'm going to run this chunk of code. Then just look at my window on the bottom right, and then you see my plot displayed there. Okay, can we see it? After I have my plot, the colors of the bar, black, the background, gray. I have female, female, and on the y-axis, I have the number, count. So you might be really interested in doing a few formatting. So let's come back and add a theme. I said the standard theme is actually gray. So we're going to put it in gray. And then we run this chunk of code again. I will see that nothing has changed because we just use the default thing. But there are a few other common themes that I want us to consider, and I'll just show us in a bit. I'll show us about 3 additional themes apart from theme gray. So you can use the theme called theme light. I will see how it looks like. Theme light. All right. The top one we're going to use is the theme minimal. I'm going to run this again. This is theme minimal. It's quite similar to theme light. I'll go back so that we can see the theme light and compare it to the theme minimal, and I appreciate the difference. This is the theme minimal. I mean, this is the theme light. It has a gray border. This is theme light. That gray border is not there. That's basically the most appreciable difference between theme minimal and theme light. But I'll show you the last one, my favorite, theme classic. I can run this chunk of code again, and this is theme classic. It's a choice to determine what particular thing would you really want. All right, the next question you might want to ask is, can we change the color? Let's assume I don't want the color of the bar chart to be black. Yes, you can. Let's try and do that. I'll come to my gem_bar where we called the geometry, and I'll change the color. The color equals navy blue. So R actually understands English version of color. It understands the RGB, that's the red, green, blue code. And it also understands the hexadecimal color codes, right? So you can use any of them. It works. So I'm going to run this again. Sorry. No, not here. I'm going to put them. Okay. And then I'm going to run this again. Okay. So this is one of the common mistakes that happens. I'm glad this is happening so that I can show us. Bar charts really don't have an appreciable color like that because color determines the border. What solid shapes like this have is what we call fill, F-I-L-L. So you fill bar charts with a particular color of your choice. So I'm going to run this again. What? What's wrong with my code? So it works now. So you can fill, and then you can change the color depending on what you want. What if you don't want it this deep? You want it a little bit transparent. Then you can set other arguments. For transparency, it is called alpha, where 0 is white and 1 is a solid color. So let's say I want to use 0.4. You can either express it as a decimal or you express it as a fraction. So 0.4 will be practically the same as saying 4/10 or 2/5. Okay, so I'm going to run this again. And I can see that it's a bit transparent. Okay, that looks good. What if I want to change the label on my x-axis here? Let's say I don't want to call it sex, I want to call it gender. the label on my y-axis, and I want to give my chart a title. Can I do that? Yes, I can. So let's do that. You add a plus and a function called lab. Is it lab or labs? LAB. Labs. Okay. Labs. Somebody's asking how do I make the bar to have a different color? I just said, I'll come to the geometry underscore bar, the geometry type, and that bar charts have a fill. So I say fill it with a particular type of color, and I'm choosing a deep navy blue. Let's say I want to choose a different color, green. Okay, so I've changed the color. We want to fill it with green, and then I'm going to run that. And we can see the color changing it. Right. So we want to add labels. We want to change the x-axis from sex to gender. So I'm going to come to labs X, and I'm going to say change it to gender. Okay. No, the two bars don't have different colors. They have the same color. Changing the bar, color for the different bars it's a bit different, but we're not covering that right now. All right. So we've changed the label of the x-axis from sex to gender. We're going to do the same for the y-axis, and we're going to change it from count to number of respondents. You can see I can have space here because I'm putting it in quotes, so it's fine. So that has also changed. Let's give it a title. Title equals sex distribution of respondents, for example. And you can run that. We can run that again, and we have the title there. Right. There are so many other things you can do, but we're not going to cover them. Right? So we have this. Yes, you can change the color and have male as blue, female as white, or anything of that, but we're not covering that right now. Okay, that goes beyond the scope of this class. So we have a title, we have an x-axis, we have a y-axis. You can continue formatting. You can format the color of the title. You can format the color of anything. Don't forget that we said theme can help us really format anything, any color that we want. You can add a subtitle if you want. Okay, we can even come and say subtitle, because this is an example data. We can run this again, and we have our subtitle there. One more, and the last thing that we will do today, you can add a caption. Source data 3-day training program. So we are putting a source for our data. Then we're going to see that again. How do you add label? We'll see that a bit. We'll see that again in a bit. So I'm going to run this again. Now we can see that we have a caption here now. Source data, 3-day training program. So let's take this again. I'm going to start afresh. We said call your data, then call a ggplot function, state what you are mapping to your x-axis, y-axis, and something like that if you want to map. For people who asked, can we have different colors? I'll do that right now. So I'm going to change this from, I'm not going to specify a color here. So it means that I want to map few color to also sex. That change the color based on their sex, right? Change the few color depending on their sex. And I think this is a good example, right? So we're going to change the few color for example, that for each different type of sex, use a different color, right? So we're mapping that to a variable called sex. We are setting the alpha transparency. We said we want it to be a little bit transparent. So we're setting it to 0.4. Don't forget, 0 is completely transparent, while 1 is a solid. Film Classic, that's the one that changed it and removed the gray background, gave us our X and Y border, and gave us this type of formatting. We add labels for our axis. X-axis, we called it gender. Y-axis, we called it number of respondents. Title, we have called it sex distribution of respondent. We have added a subtitle and we have added a caption. Very good. So let's send this again. I can see I have different colors for each of the bars. And it's also giving me a legend. And the pink is the male and this other one is the female. Lovely. I hope, Sam, this answers your question, and at the same time, Billy, this answers your question too. This is good. Right, so we have answered the fourth question. I'm going to assign this to a particular variable. I'll say sex list. So I can save it. So I'm assigning it. Nice. So if I come here, let's say I change this, and I press sex list, it will plot my graph and show me my graph. But you can see that this is a static graph, right? I can't interact with it. It's very static. And I did promise to show us a little bit about some interaction. Okay, HTML widget. So we do plotly graph. Like I said earlier, plotly has a little bit of interaction. So there is a function called ggplotly from plotly. Again, the name of the package is plotly. The function we want to use is called ggplotly. And we put the name of our plot. The name of our plot is sex_dist. Right? And I'm going to run this. And you see something unique, something beautiful. Okay? Now it's really not looking different, except that I'm going to zoom this so we can appreciate it a bit more. Now you can see that if I put my cursor over this, there's a call out. And it's telling me, oh, count is this, sex is this. The same thing for this. Right. And it's also giving me the option to click on my legend. So let's see what happens if I click on the mail. I'll see that. What about if I click on the female? Everything goes off. And then I can bring just my male up again. I can bring my female. I can interact with my axis, change it, play with it. The same thing with this. I can save it. I can download this by pressing this, and I'll download it as a PNG. And do a lot of other things using all these options up here. All right, just by calling one single function. Okay. This. So I've delivered on my promise. I've shown us a little bit of widget. Somebody's asking for me to do it again. Okay, that's fine. We did all our plots, called all these functions. Let me expand this a bit. So all these functions to do our plotting. And when we were done and we felt, oh, this is beautiful, we assign it a name and we call it sex_dist. All right? We call it sex_dist. Now we run it so that if you check my environment here, I have something called sex_dist here. Then we'll call the function called ggplotly. That is from the plotly package. And then we just did this, and we gave it the name of our variable that we just assigned here. This sex_dist. And we ran that. And boom, that was all we did. And we got this lovely interactive graph. Okay. So let's answer the fifth question. The last question. The fifth question says, plot a graph to demonstrate the relationship between the weight and the height. The graph to demonstrate the relationship between the weight and the height. Okay. Let's go back here. Let's print our data again. This is the weight in kilogram. This is the height. You can use either the height in centimeters or the height in meter. I think anyone is fine. We have agreed that weight is a continuous variable, even though R has called it integer. And also height is a continuous variable. And we said when you are plotting relationship between two continuous variables, you need a scatter plot. Okay, so we need to use a scatter plot. Right, so how do we do scatter plots in R? Again, specify your data. Then ggplot, a state mapping. You can mapping equals AES x-axis. Somebody tell me what do you want on the x-axis, sex or weight. Somebody tell me what you have on the y, what you want. Of course, the other thing is y-axis. So what do we have on the x-axis? The first question, sex or weight? Weight. Okay, so we're going to put weight on the x-axis, weight, and on the y-axis, we're going to put height. Don't forget, our height is height underscore cm. Okay, if I run this, I won't see anything because I've really not specified everything. Okay, and I have error because I don't have a weight, I have a weight underscore kg. Okay, and obviously, my mapping is, I only have this layer, the data and the mapping layer. I've not added, I'm here to add a geometry. Okay, so we said the geometry is supposed to be scatter plot. But what is scatter plot now? It's called gem underscore points. Scatter plot are point charts. All right. So we're going to call gem underscore point, and then we're going to run this again. Boom, we have it. Really, this is a lot. I wasn't expecting this. It's making our graph look kind of beautiful in a way, but you can notice a few things. Our x-axis is really not starting at 0. Our y-axis is not starting at 0. Okay, I won't bother us too much with that, but I'll show us a few things. First thing is that this graph seems to be very intense. Let's reduce the transparency so that we can see maybe there are some overplotting. All right, so I'm going to set the alpha to 0.1. In that way, the deeper the color, the more the number of plots on a single point, right? I'm going to run that again. And this looks a bit better. Okay, but obviously there really doesn't seem to be a particular pattern. Okay, but this is what the person has asked us to do. So we're still going to do this. I'm just going to add a few formatting like we did before. I'm going to change my theme to Theme Classic. I'm going to run that again. Labs x equals weight. This time around is kg. Y equals height in centimeters. And title equals relationship between weight and height. Don't worry, there seems to be no relationship because this is a simulated data. Okay, it's not really a real life data because ordinarily we know that there is a relationship between your height and your weight to some extent. Okay, this Right. So I think we've answered all the questions and we're going to pick them. So let's see how to save some of the things we have done. Okay. So let's agree on a few things we want to save. Let's say number one, we want to save our DSV underscore clean data. That's one. Two, let's assume we want to save, I'll show us just one more thing after that, how to save. Let's assume we want to save this, how many respondents from each state, the first question. So we save those two things. So one, clean data. And the clean data is, somebody said, let's have an Instagram. I'll just quickly do that. DF underscore clean. DF underscore CSV underscore clean. Then GG plus happy equals AES, X equals weight. Weight is a continuous variable. You need histogram for the continuous variable. Then the geometry is called gem underscore histogram. That's all. I run this. Again, it's weight in kg, weight underscore kg. Right. And then I have this. Okay. I can increase the number of bins by saying bin width equals 1. So 1 bin for each width. So I have this. If I want to make this more beautiful, I can say color equals white. And I have this. Okay. So this is just an example of an histogram. Right. Okay, so let's go ahead and save clean data. So recall that we said we'll be using the export function, and the export function is from the real package. So we say export. It has basically just two arguments, or three. The first is, what data do you want to export? With DSV underscore, DF underscore, DSV underscore clean. And the second argument is where do you want to put it? And what is the name? I'll go to my files again. We said this is here where your project file is here. That's where your project is starting. So we're going to say export it to here, then our output folder. So name it clean demo data.csv. Okay. Basically, the third argument that it takes that probably is important is the format. But most times you don't need to specify the format because you can decode the format from this your extension here. So it knows that it's a CSV format. All right. So let me open the output folder and we can see that it's blank. There's nothing there right now. But let's export our clean data now into this output folder. So I'm going to click run. Say error. Okay, so let me just look at that. Okay. So you have the, okay, you have the question mark in front of your function to guide you if you're having trouble. The reason why we're having the error is because I didn't assign this to file, all right? So if you look at export again, so what I did was to open the export. It says, what file do you want to export? So our X, let's call this X, is the data we want to export. Where do you want to save it? So file. I told us about the format, that the format is optional. So let's run this again. What's happening? Okay, coming format equals CSV. Really? Right. So that's fine. So I'm going to just do one more thing. I don't know why this is really giving this error right now. Let me check that we loaded here package. We did. One other thing you can do if you're having this kind of issue is that instead of using the here function, I'm going to use what we call the relative file path. So I'm going to do a dot followed by a slash. And then this one too, I'll remove this code and then a slash like this. And then I'm going to open this. So the dot here is standing from the folder where you are right now. Then change into this folder called output. And then give my file this name. All right? Then we're going to try this. Let's see what happens. Okay, so I think the problem is this. I'll try this again, and then it's fine. I'll tell us why we're having the issue right now. So that's one thing that happened. Of course, you could remove the space in the file name if you want. I decided to put the spaces. That was not the issue. What happened was that there was a conflict. All right? We wanted to use the export function, but the export was found in more than one different package that we loaded. Okay, I'll show us in a bit. Let me do question mark exports, and you'll see what comes up. Can you see here? It's saying, oh, I can find export in a package called real, and I can also find export in a package called plotly. So it was actually using the export in the plotly package, and that was not what we wanted. That was why we were getting the error. Okay, so this way I have forced it that no, don't use the export function in the plotly package, but explicitly use the export function in the real package. Right? And that solved our issue. Yes, that was because we loaded plotly after we loaded real. If it has been the other way around, it should have been using the export from the most recent package, which would have been real. All right? Okay. So we'll save this. We're going to save the second one now. And that is our, we said it's the, what's the name again? We said we're going to save the first question, number of respondents. But before we can save, we need to assign it something. Number of respondents. So I'll save this as number of respondents. Now press my Alt followed by my minus. So we're saving this. We know it's number of respondents that we want to save. Then we'll come here and say number of respondents. That's what we want to save now. So explicitly real export X equals number of respondents and file equal. I'm going to use here this time around. Here, output number of respondents by sex dot xlxx. So I'm saving that as an Excel type. And I'm not going to specify the format because I said format is actually optional. So I'm going to run this now. And you see, we have it here as an Excel file. That's how you see. Okay. Can a map be plotted? Absolutely. We can plot maps. We can plot the map of Nigeria. I use the R to plot the map of Nigeria. I have said it. I use R for geospatial analysis. Geospatial analysis is more or less like plotting maps. All right. So this is saving. I think we have answered all the questions that the person has asked us to. So I'm going to click on save. And then we're going to leave this and go back to our slides. All right. So this is where we are. Then I'll put this in Full screen mode. So we are saved. We've seen saving with Excel, saving in CSV. You can export, you can save as SPSS, you can save as Python, you can save as Stata, you can save as SAS, you can save as several file extension, XML, JSON, we just shown to, all right? You can save in most of the formats that are possible and available out there. We're just demonstrating in this class. Right, so communicating your results. Now that you have finished all the works, I said perhaps maybe the most important part of data science is the communication of results. What format can I help you communicate your results in? You can communicate it as HTML. Pardon, as HTML. So you can write a web page, communicate your results. For example, create a link to it that can be used by your organization for your report. I can do that for you and include all your data there. And every time your data changes, R can automatically just update all those data points. All right. You can use R to write words. I have written a Word document in R before. And yes, people write their thesis in R. I've not written a thesis. I've not written a dissertation in R before, but yes, you can do that. You can do all your referencing, your standard referencing and all this. Yes, you can. Let me not call this PowerPoint. Let me say slide presentation. Because PowerPoint specifically, I think belongs to Microsoft. Or maybe I think Microsoft is more of Microsoft PowerPoint. But this is a slide presentation, and I'm doing this with R, so this is a form of communication. You can save as PDF, somebody asked before. You can also save your pictures as PDF. You can save your output as PDF. You can communicate your results. You can also write all your narrative and convert it to PDF, right in R. And I will generate a PDF for you. My package, one of the package that I have called Tidy NBR has that. So for few people who might be working in the HIV sector and that use data from the National Data Repository, they might want to check the Tidy NBR package. I think you'll find it very useful. Okay, so you can easily download it, just like you download all the other functions, all the other packages. Just put Tidy NBR there. I'm going to put it in the chat box for those who want to know more about it, Tidy NBR. And if you put this also in the Google search, you will see more about the Tidy NBR. All right, that's a PDF documentation too, all written in R. You can use R to do your article. So if you want to publish, and for some statistics websites, I mean, for some statistics journals, they actually expect you to write your article in R environment, okay, or in a programming environment, so that they can also see your codes. And about the same time, abstracts. So R can be used to do all sorts of, well, let me see, many types of communication format. You can use R to record video. Yes, video is also possible. All right. A recap. I think we've learned a lot in the last 3 days, and I've been doing most of the recap. So for once, I'll ask people, please just put in the chat box one thing that you have learned over the last 3 days, and let's all learn together. All right? And while we do that, we also want to ask for one more opinion from you. So Dr. Benga, I don't know if our poll can come up right now, if it is ready, while we take the recap from our participants. So please, just in the chat box, drop one thing that you have learned over the last 3 days. All right, thank you. So I'll just give a minute for that. And I still encourage people to stay. There are a few more things to learn. We're not really altogether done, even though we're doing a recap. Right, so different packages are Studio. I'll probably say R, not R Studio. Like I said before, R is the programming language. R Studio is more like an environment that makes it easier to work with R. So what you're using is R, not really R, right? Okay, somebody say learn how to import and export. And somebody say, so how do I use the downloaded package like NDR to analyze my NDR data? Am I to open it in any script? I think that's more of what you want to do. Or what we've said, I think yesterday, is that it's better than when every time you start a new project, there's a different thing altogether. Please create a new project. I went over that yesterday. So please, if you have actually missed that session, kindly take a minute or two, or a few minutes to go over the initial videos with detailed out how to create projects. Writing and saving different kinds of data type, good. This seems quite simple and straightforward. Thank you. Now we have our poll. Our post tester is up. Please, you can just help us answer these things. We have a few of them. So never mind, just take a few minutes. So I'm going to pause for one minute while we wait for our participants to just complete the poll. I'm going to continue looking at the chat box. This has been an eye-opener. Beauty of R in comparison with other analytical tools. I've always loved R. I think it's superior to most other tools out there. But using different colors to separate bars. Okay, thank you. I'll continue. It has given somebody the driver to and motivation to continue the R journey. Thank you. Somebody really learned about the Pacman and the GGPro too. Nice. How to use scripts. Excellent. Somebody came as a novice, has installed the software, and is ginger to continue learning R. Thank you. Okay, so I think we have a lot of them. Okay, good. We have a few people that have completed our tests. Please just take a minute to complete the test. Have we finished the post test, Dr. Blinger? Can I go ahead and continue now?
Thank you so much, Dr. Balogun. I think we should allow people to, once we reach probably maybe 80%, we can continue. So we are still at 72%. Please, if you've not completed, we appreciate that you please complete this.
Interactive. Right from inside R, you can learn about R. So you can install these packages. You use the p_install function from Pacman. So I'm going to copy this and put it in the chat box. You can just run it and it will install these two packages for you. When you install Swell, of course, you will have to load it first by pressing library Swell. And when you are done loading the library, just call the Swell function. And you're good to go. It's interactive. It will keep giving you instructions and telling you what to do next. It's really lovely. I'll encourage us to try it out. The other one is the learner package. And I'm going to stop sharing so I can show us how learner looks like. I'm going to go back to my RStudio environment. Once you have a learner installed on your computer, if you look at my top right panel here, the last option is called a tutorial. So learner does that to your R Studio. It adds this more tab to the panel on the top right, and you have a few tutorials that you can try out, but it could be quite difficult to know exactly where to start. But learner offers you this, okay? Right, so I'm going to stop sharing this screen and go back to the slides. I encourage people to join the community if they have the time. Our studio community really gives a lot of learning opportunities and helps you to troubleshoot some of the challenges that you might have. I'll put the link there. There are also learning platforms, useful learning platforms that you might have, say resources that you can learn anything or two from. Coursera offers a few things in R. edX does that, Udemy, and you can see free videos available also on YouTube. Okay, so for me, where do I go from here? I'm open to collaboration. So if you have our projects, our works that you think we can work together on, please reach out. I'm open to collaboration. I can do trainings, I offer training opportunities like this. Okay. But going forward, generally the free classes are frequent, infrequent and are wide apart. I do paid trainings, I do paid classes. So you can reach out if you want to learn more about that. I also do jobs. I analyze data for people, PhD dissertation, and any other data that you might want to have analyzed. Please reach out to that. And right now, together with my brother, who is also on this call, we're trying to put together a teaching platform. So when that is available, I can't tell exactly how soon, but it's going to come up soon. And we're hoping that people will be able to subscribe and then a few other things from the teaching platform. It's not likely coming out this year. So please, I don't want you to bank on that, but it's definitely something we are working on in the nearest future. If you want to reach me, please feel free to reach at me. Reach me via the Twitter. That's my Twitter handle at @epidog. And this is my LinkedIn. You can send me a friend request and you can send me a personal email. Just one more thing from me, please. I'll kindly appreciate if people understand that this is the end of the training, the free training. I am not available to provide support that you might really need with your R journey going forward out on a free platform because generally my schedules are tight. So I might not really be able to provide unpaid platform support for you. But I'm hoping that when you go ahead and review these videos and with all the resources that I've put here, you should be able to troubleshoot and support yourself going forward. But please, I again kindly like that people respect that I might not be able to provide support if they send me personal emails or start me up regarding a few challenges they're having with R. But if you have trainings for me, if you have jobs for me, please feel free to reach out. Right, I think that's the end for me. Please, if you have questions that you want to ask me, please put them in the chat box. Don't go yet. Our facilitator has a few instructions that you want to pass across or a few other follow-ups for us. I'm going to drop the link for this presentation today and the link for the presentation for that of yesterday. I'll drop them in the chat box. And I trust that our facilitator will also get them across to us in addition to the video from today's session. All right, thank you and over from me.